Okay, when you look at this question, so the wedge of cheese is in the shape of a triangular prism. The base of the wedge is 8 centimeters long as shown. A similar wedge of cheese is cut from the large wedge of cheese as shown in the diagram. The cut is made at a distance of d from the back of the wedge, and you can see all of that in the diagram. So the volume of the smaller wedge is half the volume of the larger wedge. So they've told us here, they've given us a little bit of information. Pretty much they're giving you the volume ratio. So if you think about it, the volume ratio is, we can say, because they said twice, maybe 2 to 1. So what we're saying is if that's the larger wedge and that's the smaller wedge. So we know we can use that to compare, but we also need to have an actual number. So if you look up here, if you think about the volume of a shape, the volume of a shape is always the area of the face times the length. So we're going to think about that. So first of all, we got to think about what is similar here. What is similar is the actual, this triangle here. So if I draw that out, that's the smaller wedge. So we got a smaller wedge, and I'm going to say it is 8 minus d. And then it's similar to this whole big larger wedge here. And the larger wedge face looks like this, is actually 8. Okay, so they're the similar. So we have here, we have a length ratio of the wedges. So the length ratio, if I say large to small, we've got 8 to compared to 8 minus d. Okay, so what we have to be careful of though is that this the similarity is only in the length and the area, because if you have a look, they're both the same length here, so, or like distance of that way. So if you were finding the area of this one, it would be the area of its face. Sorry, if you're finding the volume, it'd be the area of its face times its length. And same with this one. If this one's volume would be the area of its face times its length. But say, you know, I've called it whatever, I've called that length here length. They're getting times by the same thing in these two. So they're not, it's not similar. So their volumes are similar in actually their area ratio. So we eliminate the area, and their volumes will be similar to their area ratio. So we're going to go find their area ratio using the numbers. So remember, we get that by squaring, and 8 minus d. So that's what's similar. And because we know their volume is a 2 to 1, so therefore down here we can then solve and say, you can just write 2 over 1 must equal 8 squared over 8 minus d squared. And then because you only have, comma, d, because you only have one unknown, you'll be able to work out what d is and therefore solve it. So d ends up being 2.3. Okay, so we got that one. So what you need to be careful of is whatever they're similar in, that's like, I think we had something like this before. So just think about it, if only 2 of the sides or 2 dimensions are similar, then you would compare like that. So you can see you cut out the length. Okay.